Hello. So today we discuss about the types of data structure called queue. So queue is an important structure for storing and retrieving data. Hence, it is extensively used among all the data structure. Queue is just like in any queue, like we make a queue to buy bus ticket or a film ticket, or sometimes to take food from KFC. That is we call as a queue. So basically queue follow the FIFO mechanism. FIFO means first in first out mechanism. So in that case, the item which will get in the queue first will get out from the queue first. Okay, similarly the second one that entered in the queue for the second position will go out after the first. Okay, so this is called a queue data structure. So in queue data structure we have actually various types of queue data structure. Okay, so when I say types of queue in data structure, we have basically 4 different types of queue. So first one is simple queue, or we can say normal queue. In simple queue or normal queue, we have 2n. One n for insertion and another one for deletion. The n from where we do the insertion is called the rear n, and the n from where we do the deletion is called the front n. Okay, so insertion will be done from the rear end and deletion can be done from the front end. All the nodes in the normal queue are connected to each other in a sequential manner. The pointer of the first node point to the value of the second. Similarly, the pointer of the second is point to the value of the third, and so on. The first node has no pointer pointing towards it, whereas the last node has no pointer pointing out from it. That means in the first node we don't have any connection coming towards it, and similarly in the last node there will be no pointer is going out, and that is in the case of normal queue. Then second type is circular queue. So unlike normal queue or simple queue, in a circular queue each node is connected to the next node in sequence, but the last node pointer is also connected to the first node address, which is missing in the simple queue, and that makes the queue circular. Hence, the last node and the first node also get connected to making a circular queue. So that is the circular queue as you see in the diagram. Here also insertion will be done from the rear end and deletion is done from the front end. And to keep track of number of items present at a particular time, we use another variable called count, so that we can at a particular time we can say how many numbers are there in the circular queue. Then third type is double-ended queue, which is also called DQ. So in case of double-ended queue, it is an exceptional case where insertion and deletions are both done from rear end as well as the front end. That means you can insert an item from the rear end, even you can delete an item from the rear end. Similarly, you can insert an item from the front end as well, and deletion also can be done from the front end. Okay, it is only possible in case of double-ended queue. In all other queue, mostly the insertion is done from rear end and deletion is done from the front end. So since insertion and deletion can be done from both the side, it is called as the double-ended queue. Now the fourth type, that is called priority queue. It is a special type of queue. In priority queue, makes the data retrieval possible only through a predetermined priority number assigned to that particular data items. That means already every data items in the queue are assigned with a predefined priority number, and based on that number we can retrieve a data or we can delete a data from the queue. And since priority is associated with each data items, it is called a priority queue. So basically when we say queue data structure, we means these four different types of queue in a data structure, queue data structure. So now we start to discuss first the simple queue or normal queue. As I told you earlier, like in this types of queue, the insertion will be done from one end and deletion will be done from the other end. Here insertion will be done from the rear end, whereas the deletion will be done from the front end. And the default value of front is assumed as 0, whereas the default value of rear is assumed as -1. In case of simple queue, we have basically three different types of operation that can be performed on that queue. The number one is insert an item at the rear end. Similarly, number two, delete an item at the front end. And the third is display the content of the queue. So in normal queue, these three different functions are performed. Now we discuss these three functions one by one. So number one, insert a item at the rear end. So since in case of normal queue, insertion is done from the rear end, so we have three different steps that we have to follow to insert a item from the rear end in a queue. So these three steps are: first, we have to check whether the queue is full or not. So in this case, we assume that the queue is an array of a particular size. Since items are inserted from the rear end, so if that rear value is equal to queue size -1, then we assume that queue is full. So insertion is not possible. Now why queue size -1? Because we think that our queue is an array, and normally array indexes are starting from 0. So that's why we have to check the rear value with queue size -1. That means assume that our queue size is 5. So that means if rear value is equal to 4 already, that means your queue is full. Since array index always start from 0. So if queue is full, then insertion is not possible. So we return back to the main function. Then number 2, if queue is not full, then what we have to do? We have to store the value that we want to insert in the queue in a variable called item. After that, after insertion, then third step is we have to increment the rear value. Whatever may be the rear value right now, we have to increment that rear value with +1. And with +1, we got a new rear position. And in that new rear position, we have to insert that item in the queue. That means if say rear is already 1, then first of all we have to increment rear is rear plus 1, that means 1 plus 1 is 2. At the 2 position, new rear value position, we have to insert the item. Okay, so as you see there, there is a function we use to insert that item in the rear end. So this is a function called insert. The function name is insert. There will be no argument. It is a no argument, no return type function. So first of all, we use a if statement to compare the rear value with q size minus 1. So if that is true, then it will print q is full and it will return back. Else, if it is not full, then first of all, there will be a printf statement. That means we have to take a item from the user, and that item, that value is stored in the item. After that, rear is equal to rear plus 1, and a rear, a is the array, a rear means the new rear position, we have to store the item. So this is this function we have to write in the program to insert a item in the rear end. So number 2, delete an item from the front end. Like insertion, we have different steps to delete a item from the front end. So the first step, first we have to check whether the queue is empty or not, because if the queue is empty, that means we don't have any value to delete. So first of all, we always have to check whether the queue is empty or not. So for that, if front value is greater than rear, this is the condition. That condition is only possible when queue is empty. In case of queue is empty, always front value is greater than rear. So if that condition is true, that means the queue is empty and the deletion is not possible. Else, if queue is not empty, then we have to return the value in the front position of the array, and after that immediately we incremented the front value by 1 so that it will point to the next item to be deleted. Okay, that means at that particular time the front is pointed to the number which is deleted, which we want to delete. So once we return that value, immediately we have to increment the front value so that it will point to the next item to be deleted. So once the front value is incremented, immediately we have to check whether that front is equal to rear or not. That means after maybe one deletion, the queue may be empty. So for that checking, we have to immediately, after deletion, we immediately have to check whether the front is greater than rear or not. If yes, then we have to initialize the default value for front and rear. That means if front is greater than rear after deletion, then we have to initialize front is equal to 0 and rear is equal to -1. So these 3 steps we have to follow to delete an item from the front end of a queue. So now you can see the delete function. So the function name is delete. So this is also a no argument, no return type function. So first of all, to check whether the queue is empty or not, what we do, in the if condition, we write front is greater than rear. So if front is greater than rear, that means queue is empty. If this is true, it will return back to the main function. Else, it will, in the printf section, it will print the front value, front position value of the array. Once it will be printed, the front is immediately incremented by 1. So after front is incremented, we again check that after increment whether that front is greater than rear or not. If it is that front is greater than rear, we initialize the default value of front and rear. So in that case, front is equal to 0 and rear is equal to -1. So this is how we delete an item from the front end of a normal queue. So these two functions we have to write using an array to insert an item as well as to delete an item. Next comes the third function, display the content of the queue. So this function is used at a particular time. How many items are present in the queue, we can display that items in the output. So in that case also, first of all, before display, we have to check whether the queue is empty or not. Because if queue is empty, then nothing to display. It is blank. Okay. So first of all, first step, we have to check whether the queue is empty or not. So how can we check? We already discussed it. If front is greater than rear, then queue is empty. So you can see the display function. Display function is also a no return type, no argument function. So here, first of all, we take a variable I for the counter, and first of all we check front is greater than rear or not. If yes, then we print queue is empty. Else, we have to print the queue elements. So for that we use the for loop. For loop means here we take a variable called I, which is act as a counter. So I is initialized with front value and it will goes up to rear, and one by one it will print the items. That means it will print the items from the position from front to rear. So within that range, all the items are present in the queue, and it will print that with the help of a for loop. So where front is initialized with I, and that I will go up to rear by incrementing one position at a time. That means I is equal to I plus 1 increment in every time. Okay. So this function will display the content at a particular time. And this tree function, using this tree function, we can write a normal queue program using C or C++. Whatever may be the programming language, the logic is always same. So using this logic, you can write the C program or C++ program for a normal queue. But here I mention using C. Okay. So with a menu and with this tree function, we can easily write a program for normal queue. So today we discussed a program about DQ. The full form of DQ is double-ended queue. Okay. So I already provided the PDF for DQ and about all the functions. So here in this video I described mainly the functions. So in last class we discussed about three functions of the queue. Okay. That is insert from rear, delete from front, and display. So in case of DQ, we have 5 functions. Why it will be called as DQ? Because here insertion is done from both the ends. Similarly, deletion also can be done from the both the ends. So here all total we have 5 functions. Insert from front, insert from rear, delete from front, and delete from rear, as well as the display function. So as I start the program, that program is more or less similar with the queue program with additional 2 functions. Okay. So here are the header files. Then we use a preprocessor max, which value is 5. These are the initial value, front is 0, rear is -1. Then we take a variable called item where we store the item. Then we have an array whose size is max. That means ultimately the size is 5. Now these 5 are the functions. This function refer to the insert from front. Second will be insert from rear. Third, delete from front. Fourth is delete from rear. And the fifth one is display. Now the main functions. Okay. So main functions we have we take a C for store the choice for the menu. Then while one, we already discussed it, while one means always true, that means this part will be repeated until we press exit. First of all, first printf for print the menu. Okay, then we take the choice. Since it is a menu driven program, we use switch case, and for each case we write one function. Like for the 1 we insert from front, for 2 insert from rear, for 3 delete from front, for 4 delete from rear, 5 display, and 6 is exit. And if we press other than 1, 2, 3, 4, 5, 6, then it will shows as a wrong choice, and we put this condition as a default. Now one by one we start the function. First of all, insert from front. In our previous program we already discussed the second function, that is insert from rear. In case of double-ended queue, double-ended means two-ended. That means from one side we can insert and delete, and from the other side also we can insert and delete. That means insert can be possible from the front side as well as in the rear side. So in first function, insert from front. So for insert from front, here we take an item. First of all, we check whether our queue is empty or not. How we check? If it will be in the initial condition, that means if front is greater than 0 and rear is -1, that means our queue is empty. In that case, front insertion is not possible. Here always we have to use the rear. Then we have to use rear is equal to rear plus 1, and the incremented rear position we put the item. It will be like our second functions. Otherwise, if front is not equal to 0, that means where it will be possible, that means if we delete one item from the queue, then our front is not 0. So in that case it will be possible to insert from front. So in that case, first of all we decrement the front value, and at that new front value we put the item. Okay, besides these two conditions, front insertion is not possible. Clear? Now come the insert from rear, which we already discussed in our previous class. So first of all we check whether our queue is full or not. If it is full, then insertion is not possible. Else we take the item, increment the rear value, and at new rear value we put the item. Okay. Similarly, here delete can be possible from two sides. Normally in normal queue we delete from front, but here we can delete from front as well as delete from rear. So delete from front, it will be similar with our previous program function. So first of all we check queue is empty or not. Then if queue is not empty, then first of all we take the array front value, and front value will be incremented. That means we delete this item and front value will be incremented. After that we will check whether front is greater than rear or not. If it is true, then we initialize the initial value of front and rear. Similarly, here we can delete a item from rear position also. Where it will be possible? First of all, obviously we have to check the queue is empty or not. If empty, that means there will be no possibility of any deletion. Otherwise, we delete the item of the A rear position, and then we decrement the rear value. That is the difference. Here we increment the front value, but if we delete from a rear position, then we decrement the rear value. Okay. Again we have to check after deletion, if front is greater than rear, then we have to initialize the initial value of front and rear. Now comes the display function, that is totally similar with the normal queue. Here we have to first check queue is empty or not. If not empty, then we have to print from front to rear, because front is the first part from where we delete the item, and rear is the position from where we insert the item. So we have to delete the queue from front to rear. So here I will be initialized as front, and it will be goes up to rear, and we print the item. Clear?